Thanks for attending the webinar. My name is Dr. Joseph Debé. I'm a board-certified nutritionist practicing in Great Neck, New York. Our topic this evening is reversing the #1 cause of illness, obesity, and accelerated aging. Let me start off with an iceberg analogy. Disease or a person's signs and symptoms are like the tip of an iceberg. The important thing is what's below the surface. To me, it's not so important to name the condition. It's important to understand what's causing it. Conventional medicine often doesn't even consider what the cause is. In general terms, the cause is altered physiology. Things aren't working properly. And what causes that? That's an interplay between genetics and factors that we have a lot of control over. Genetics are of minor importance in most cases compared to the modifiable factors that we can change. Toxicity, we'll be talking about that in some detail. Anything that builds up in the body beyond a certain concentration becomes toxic, damaging, alters functioning in an unhealthy way. Even the body's own biochemicals become toxic at some level. Medications are a source of toxicity. Waste products from bacteria and other organisms within the intestinal tract. Mercury from silver fillings in the teeth. Those are some of the sources of toxicity in addition to environmental toxins. Stress. For some people, stress is the dominant factor. So it's important to assess and deal with sources of mental emotional stress. Food allergy. For some people, this is not an issue. For other people, it's a major issue. Food reactions can be inherited, genetic, or they can be acquired. And there are different tests to look into these. Nutrient deficiencies. Not getting enough nutrients for your body to work the way it's designed to. Everyone's unique in that regard. And hormone imbalance. And we'll be focusing on several hormones, one in particular, which is called insulin. A lot of people believe that a person is either healthy or they're sick. Really, there's a continuum between health and disease. And most people fall somewhere in the middle. They may have a diagnosed disease, but before they get there, there's a process of dysfunction that's been going on for some time. So on the right, we have optimal function, which we can always strive for. And on the other end, we have advanced breakdown in the body. How do we go from optimal function to advanced breakdown? That doesn't happen overnight. There's a process of altered cellular function, and then we get dysfunction of whole organs, for example, the heart, the liver, kidneys, pancreas, muscles, and eventually things deteriorate to the point where a label could be given to the process as a disease. With optimal function, we feel fine. With altered cellular function, initially we feel fine, but when things become more advanced, then the body lets us know there's something wrong with signs and symptoms. Signs are what can be measured, and symptoms are what we feel. Conventional medicine deals in end-stage breakdown, detecting disease with tests like X-rays, angiogram, biopsies. There's some exceptions to this, but mostly conventional medicine deals with disease. When it comes to breast cancer, for example, preventive tests by the standards of conventional medicine are tests that are really picking up the disease at an early stage. So a mammogram will identify the presence of a small tumor. To me, that's not really prevention. That's early detection. Detecting the disease at an early stage. But what's even better is to pick up things earlier on, before the disease has developed, before the tumors developed. And when it comes to breast cancer, an example is a test called an Estrenex test. The Estrenex test you can read about on my website, drdebé.com. Click on the tab for special tests, and you can read about the Estrenex test. Functional medicine deals with the realm of suboptimal wellness and more subtle dysfunction before the onset of major disease. People who have disease can be helped by functional medicine, but functional medicine is unique in identifying problems very early on with tests like tests of nutrient deficiency, toxicity, special metabolic tests. So with a good functional medicine workup, we can help a person before they progress to advanced disease. One person could go to a doctor with all these different complaints: high cholesterol, high blood pressure, obesity, depression, pain, and they can wind up getting a different medication for each one. Or maybe they go to several different specialists and get different medications from different doctors. All these different conditions are tied together by unhealthy physiology, by imbalance in the body's biochemicals. And this imbalance is a result of factors we have a lot of control over: stress, toxicity, nutrient imbalances, inadequate rest, improper exercise, inflammation, food sensitivities. So if we can work upstream and deal with these causative factors that are largely related to lifestyle and influences we have control over, we improve the physiology, we improve these conditions, and we reduce our need for medications. And the thing I'm going to focus on this evening is the hormone insulin. Now, insulin doesn't function in a vacuum. Insulin isn't the single most important chemical in the body, but it is one of the very important hormones when it comes to health, illness, and aging. Insulin is released in response to high blood glucose or sugar levels. Insulin is an anabolic or building hormone. It transports nutrients into the cell, including glucose. And the glucose that isn't burned for energy is stored as glycogen. Once the glycogen or carbohydrate stores are filled, the excess glucose gets converted to fat. That's what lipogenesis is: fat formation from excess calories. Insulin stimulates that. Insulin also stimulates protein synthesis and promotes mitosis, or cell division. And what types of cells are rapidly dividing? So the most rapidly dividing cells are cancer cells. And we'll be talking about the influence of insulin on cancer. This is a little description of blood sugar metabolism. On the left, we have healthy blood sugar metabolism. On the right, unhealthy blood sugar metabolism. This represents a healthy diet. This is a whole foods, unrefined diet. On the right, we have a lot of junk foods, a lot of high sugar foods. This is the intestinal tract where food is digested. This is the pancreas, the organ in the upper abdomen that produces insulin. This is a cross-section of a cell. The cell is a microscopic unit of structure of the tissues in the body. So for example, this represents a muscle cell. If you think of a cell like an orange, the peel is a membrane. This is the membrane. The membrane holds the cell together, governs what goes into the cell like nutrients, what comes out like waste products. And within the cell membrane are receptors for different hormones. These are insulin receptors. Inside the cell, there are many different structures. This is the nucleus. or the brain of the cell. This is where you have the DNA, the genetic code, the blueprint for all the biochemicals the body can make that go into forming structure and running chemical reactions. This is mitochondrion, where food and oxygen are combined to produce energy. Glucose or sugar, little dots, need the help of insulin to make their way into the cell to be burned for energy. When we eat food, it's digested in the intestinal tract. Glucose is absorbed. That stimulates the pancreas to release insulin. Insulin attaches to a receptor on the cell membrane, sends a signal into the cell. Glucose transport vesicles go to the cell membrane, transport the glucose into the cell, and most of it gets burned in the mitochondria with oxygen to produce energy. You need energy for all your cellular functions, and if you don't have enough energy, not only do you feel tired, but your organs become weak, more susceptible to disease. Nothing works as well as it should. You don't burn calories, more likely to put on fat. For all this to happen efficiently, there's a lot of things that have to be working properly, and you need the right levels of different nutrients. Can't make these words out, but EPA and DHA, omega-3 fatty acids, have to be present in the cell membrane in order for the insulin receptors to work efficiently. You need vanadium, chromium, CLA, lipoic acid, inositol, magnesium, vitamin E for different aspects of insulin signaling and glucose transport into the cell. Okay, on the right we have unhealthy blood sugar metabolism. This is a high sugar diet. We could also put white flour products here like bagels, muffins, bread, pasta, also potatoes, rice, excuse me. These foods, these starches are chains of sugars. That's what a starch is. It's a chain of sugars. And these types of sugar chains are rapidly digested in the intestinal tract, liberating sugar that's rapidly absorbed into the bloodstream. So on the right unhealthy side, there's a number of problems. There's too much glucose, sugar coming into the bloodstream. These insulin receptors don't work well. You see these insulin receptors look different than these. This represents a very important abnormality called insulin resistance. So these insulin receptors don't work well. So when you eat this type of diet, you get a lot of sugar coming into the bloodstream all at once. The pancreas responds by making a lot of insulin to try and transport all that sugar into the cells. But if the insulin receptors don't respond efficiently, the sugar doesn't get transported. Initially, when this starts to happen in a person, the body compensates by making more insulin. And that's good because it gets the sugar into the cells. But it comes at a cost. High insulin has a lot of negative effects in the body. Not only does insulin transport sugar into the cells, insulin is a fat-building hormone. It interferes with the burning of fat. So if you're producing a lot of insulin, you're going to wind up with trouble with your weight, especially fat around the middle. Insulin stimulates inflammation. And all the degenerative diseases have an inflammatory component. Insulin stimulates blood clotting, contributing to cardiovascular problems. Insulin stimulates the growth of certain cancers. We'll be getting into the negative effects of excess insulin in just a minute. So a lot of things that contribute to this insulin resistance process. So we can have problems with the insulin receptors, and one of the factors here is not having the right types of fats in your cell membrane. And then you could have impairment in relay of the insulin signal into the cells. One of the factors that contributes to that is inflammation. And then you don't wind up with good glucose transport and energy production, and nothing works as well as it should with impaired energy production. With insulin resistance, people commonly have mental fogginess, low energy, depression, increased fat, decreased muscle mass. This shows the continuum from optimal glucose and insulin metabolism to advanced diabetes, where a person has to inject insulin. And people don't go from normal to diabetic overnight. There's a process that takes place over time. And this process is largely the result of things we do, bad choices we make. So let's say, for example, you eat a lot of refined carbohydrates over and over again, high sugar foods, let's say a donut and a sugary drink for breakfast, bagel for a snack, pasta at lunch, candy for a snack in the afternoon, French fries with dinner. That's a lot of sugar all day long. Your body's continually experiencing a roller coaster of blood sugar. Your blood sugar goes up, and your pancreas has to make a lot of insulin. And the pancreas often overcompensates, makes too much insulin, and that drives the blood sugar too low temporarily. And when your blood sugar drops too low or too quickly, you get symptoms. You can get tired, moody, irritable, headaches, difficulty concentrating, fall asleep if it goes too low. And then the next step that happens when this process continues over and over again is insulin resistance. Your cells begin to tune out the insulin signal, and then the blood sugar starts creeping up. And then you get secondary side effects. And this is still going to be considered normal blood sugar. But when you get to this point called metabolic syndrome, you wind up with problems with your cholesterol, your blood pressure, and problems in other areas. And then your blood sugar is going to rise to a point that's called diabetic. Then the final stage, the pancreas becomes exhausted, damaged. There's not enough cells left to make insulin. Your insulin levels fall, and your blood sugar goes up higher, and you need to inject insulin. Now the good news is that up to a point this is reversible. And most people that have problems in this area aren't going to wind up needing to inject insulin. Most of them aren't even going to become diabetic. But most of them will die from a condition related to this process under the umbrella of metabolic syndrome. So we want to do everything we can to reverse this process. It's best to reverse it early on before things become advanced, but even a diabetic potentially can reverse this process. Okay, we're going to talk about some of the damaging effects of high insulin and insulin resistance, which go hand in hand. When the insulin doesn't work well at the cell level, the body compensates by making more insulin. High insulin can further worsen the insulin resistance. Insulin has bad effects on your cholesterol. Causes the body to convert good HDL cholesterol into bad VLDL cholesterol and triglycerides. Insulin stimulates an enzyme in the liver called HMG-CoA reductase, which produces LDL, or so-called bad cholesterol. This enzyme is the target of the billion-dollar blockbuster cholesterol-lowering drugs, the statin drugs, Lipitor, Crestor, Zocor, those drugs that are given to people with high cholesterol. They shut down this enzyme, HMG-CoA reductase, and that can produce a lot of side effects. Insulin has the opposite effect. It stimulates that enzyme. Most cholesterol in the blood is made in the liver. I can lower people's cholesterol or help them to lower their cholesterol in many cases by getting their insulin to work better. Get their insulin to work better. They don't make as much insulin. There's less stimulation to this enzyme, and the LDL or bad cholesterol goes down. And this has been known since 1974, if not earlier. But doctors don't seem to pay attention to this issue. I'm going to show you a case study. Tom was a patient of mine, would see me for chiropractic. I'm also a chiropractor. He would see me for chiropractic, sports nutrition. He was a competitive athlete, world-class competitive athlete. And during this time, I advised that we do a good holistic nutritional workup to see what areas we could work on to make him even healthier. But he didn't really have an interest. So I would say on this continuum, he was probably over here somewhere. He was feeling pretty good, but I think he had room for improvement. Then one day, he gave me a call. And he came in to see me. He had high blood pressure. I did an evaluation on him, learned what had been going on with him, recommended he do a test called a carbohydrate challenge test, which you can read about on my website. That's a test that looks for insulin resistance. About half of people with high blood pressure have high blood pressure because of insulin resistance. So I suggested this test, but Tom didn't follow through. Didn't hear from him again for a while. So at this point, I would say he had become more unhealthy. His high blood pressure is a sign of things not working properly in the body. And then things got worse. He worked cleaning up at ground zero. He was under tremendous stress at home. He was eating a very imbalanced diet. He was eating a big quantity of beef several times a day. He was overdoing certain nutritional supplements, which may have been a factor. Drinking a lot of coffee. He used a potentially toxic medication called Lamisil, and he developed a lot of symptoms. Fatigue, frequent urination, extreme thirst, lethargy, weakness, joint pains, constipation, blurry vision, poor wound healing, poor balance. He would fall asleep at work, terrible memory. And the last straw was when he lost 30 pounds in 5 weeks without trying. That got him concerned. He got a referral to a doctor, an endocrinologist who worked at a hospital, and he went to see the doctor on August 5th, 2002, called me up after the visit and said, "I'm diabetic. Can I see you tomorrow?" I said, "Okay." Came in to see me the next day. His doctor put him on insulin and another medication called Amaryl. And Tom asked me during our visit the next day, if he followed my program, how long it would take for him to get off his medication. I wanted to be optimistic, but I didn't want to overpromise, and I was a little bit concerned with the number I came up with. I came up with 12 weeks because it takes about 12 weeks for the fatty acids in the cell membranes to turn over, to change. His numbers were so bad, 12 weeks is probably a little bit overambitious. This is a copy of his blood test report. His blood glucose was 730. The laboratory says normal's from 70 to 115. His numbers were so bad they were surprised he wasn't in a coma. His cholesterol was 494. The liver enzyme could not be measured. It says here, not performed. Interference due to gross lipemia. That means fat in the blood. His blood, a tube of his blood looked like grease. This test couldn't be run because there was so much fat in his blood. His numbers were so bad they shut down the laboratory in the hospital. They thought there was something wrong with the equipment. They reran his tests and got the same numbers again. His triglycerides, normal's up to 200. Triglyceride is basically fat. His was 6,097. So at this point, I would say Tom had deteriorated into the disease category. We put him on a program, strict, healthy diet, a lot of changes with his diet, nutritional supplements to get his insulin to work better and address some other issues, but that was the target of his approach, was to get his insulin to work better. Cardiovascular exercise, and he was a model patient, and he did great. So I saw him on August 6th. August 14th, he was doing much better, gradually decreasing his insulin while adding and increasing an oral medication, glucophage. 2 weeks later, he had stopped his insulin altogether. And just 6 weeks after we began our program, we did follow-up blood testing, and these were his numbers. His blood sugar was 106. Triglycerides were 221. Cholesterol was 146. And a couple of weeks later, he was off all his medication. And we had restored his health in a short period of time. All this could have been avoided if Tom had pursued early evaluation and personalized nutrition and health promotion rather than using a reactive approach, rather than waiting for things to get bad and a diagnosis to be made. When it comes to insulin and cholesterol, there's a lot of adverse effects. This represents an artery. This is a cholesterol particle. When you get a measurement of your cholesterol on blood testing, that number is a result of two things: the number of cholesterol particles and the density or weight of the particles. This represents what's called a large particle. It's also referred to as pattern A. Large particles kind of bounce off the artery wall. Small, dense particles, or sometimes referred to as pattern B, these don't bounce. These contribute to plaque buildup in the arteries. So you don't want to have pattern B, you want to have pattern A, large, buoyant particles rather than small, dense particles. Small, dense particles are stimulated by insulin. Here's another patient of mine. These were his initial results. Cholesterol was a bit high at 230. HDL, good cholesterol, was too low. LDL, bad cholesterol, was too high. Triglycerides were too high. His insulin is too high. C-peptide is also related to insulin, too high. ALT, an enzyme telling us that there's liver stress, maybe fatty liver, which you commonly see with insulin problems. Ferritin was high, telling us that there's too much inflammation. And he had those small, dense LDL particles. Put him on a program to get his insulin to work better. And we tested him about 5 months later. His cholesterol, total cholesterol was down. HDL, good cholesterol, was up by a third. LDL, bad cholesterol, was down. Triglycerides, better than cut in half. And his triglyceride HDL ratio is much improved. That's an important value to look at. Triglyceride to HDL ratio is strongly connected with insulin resistance. The higher that ratio, the more insulin resistance. His insulin, fasting insulin, had improved, C-peptide had improved, liver enzyme improved, less inflammation, and his LDL cholesterol particles had become large and buoyant, less likely to do damage in the arteries. Insulin also influences blood pressure. Arginine is an amino acid your body converts to a gas in the arteries called nitric oxide, which causes the blood vessels to relax, expand, and when that happens, there's less pressure inside the vessels. Your blood pressure goes down. Insulin impairs this process, reduces the production of nitric oxide, your blood vessels constrict. So like I mentioned before, half of people with high blood pressure have it due to insulin resistance. Insulin resistance causes diabetes. No, it causes high triglycerides. No, it causes high blood pressure. Insulin resistance causes all kinds of things. There's a condition called metabolic syndrome, which is a constellation of different abnormalities that result from insulin resistance. Increased waist circumference, elevated triglycerides, decreased HDL, elevated blood pressure, elevated blood sugar. And if you want to read a little bit more about this, go to my website, drdebé.com. Click on the second article, the name of this webinar, Reversing the #1 Cause of Illness, Obesity, and Accelerated Aging. And you can learn about the details of the classification of metabolic syndrome. Okay, I've compiled a partial list of things that result from high insulin. That's what hyperinsulinemia means, and insulin resistance. High blood sugar, high triglycerides, low protective good cholesterol, HDL, dense LDL particles, increased apolipoprotein B. This is a protein that delivers the bad cholesterol to the artery wall, contributes to plaque buildup. You can measure this apolipoprotein B on a blood test. It's more important than the cholesterol itself. Higher uric acid concentrations. Uric acid contributes to gout. Increased ADMA, that's an independent cardiovascular risk factor. Reduced nitric oxide. Increased peroxynitrite, that's a bad free radical in the arteries. Oxidative stress, that's free radical excess. Increased inflammation. Increased blood clotting. Arterial smooth muscle cell growth. These are all bad things for your arteries. Low testosterone and high estrogen in men, higher blood pressure, type 2 diabetes, heart disease, stroke, erectile dysfunction, impaired cognition and memory, fatigue, stress and anxiety, impaired wound healing, immune suppression, sleep apnea, gout, kidney stones, hunger and carbohydrate cravings, too much fat around the middle, fatty liver, and cirrhosis. I believe I've heard about 70 million Americans have fatty liver. Most of that's connected with this insulin resistance. Sarcopenia, loss of muscle, the most important change that occurs in the body with aging. Large birth weight, high testosterone and estrogen in women, acne, PMS, early onset of menstrual cycle, polycystic ovary syndrome, Alzheimer's and other neurodegenerative diseases, gastroesophageal reflux disease, allergy, inflammatory bowel disease, and other autoimmune diseases. Cancers of the colon, breast, and prostate. There may be others, but definitely these three have been connected with insulin resistance. Insulin is a growth factor and stimulates the growth of these cells. Osteoporosis. Here's a study entitled Association Between Metabolic Syndrome and Depressive Symptoms in Middle-Aged Adults. Our results suggest that the metabolic syndrome, in particular the obesity and dyslipidemia, that's cholesterol and triglycerides components, is predictive of depressive symptoms. Another study entitled The Metabolic Syndrome, Inflammation, and Risk of Cognitive Decline. Compared with those without the metabolic syndrome, elders with the metabolic syndrome were more likely to have cognitive impairment. So if you have insulin resistance, it can affect your thinking ability. And this one is entitled Alzheimer's Disease is Type 3 Diabetes. We conclude that the term Type 3 diabetes accurately reflects the fact that Alzheimer's disease represents a form of diabetes that selectively involves the brain and has molecular and biochemical features that overlap with both Type 1 diabetes mellitus and Type 2 diabetes mellitus. A lot of cases of Alzheimer's disease, I believe I've heard about half, are probably due to insulin resistance. Androgen imbalance in women. Nearly 10% of all women have some form of androgen or male hormone imbalance, and the symptoms include irregular periods, infertility, unexplained weight gain, apple body shape, fluid retention, fatigue, mood swings, acne, hair loss, unwanted hair growth like in the face. Insulin causes conversion of progesterone into testosterone. Here's a study that really, I think, justifies insulin resistance as being one of the most important factors in aging, in unhealthy aging. 208 apparently healthy, non-obese men were evaluated for how well their insulin worked, followed for an average of 6 years. They were divided into 3 groups based on how well their insulin was functioning. And they were checked for the development of hypertension or high blood pressure, heart disease, stroke, type 2 diabetes, and cancer. At the end of the study, 37 men developed one or more of these conditions. 12 developed hypertension, 2 developed diabetes, 3 developed hypertension and diabetes, 7 developed heart disease, 4 developed stroke, 9 developed cancer. And when they examined which groups developed these conditions, 28 out of the 40 clinical events were seen in 25 individuals with the most insulin resistance. The other 12 diagnoses were seen in the intermediate degree of insulin resistance. There were no clinical events in the most insulin-sensitive group. The men in the group with the best insulin functioning remained totally free of those conditions. 1 out of 3 men in the other groups developed one or more of those conditions. The title of the study is Insulin Resistance as a Predictor of Age-Related Diseases. And insulin resistance appears to be a major factor when it comes to age-related diseases. If you want to experience healthy aging, you want your insulin to work well. Over a lifetime, insulin resistance can contribute to so many different conditions. This is just a few of them. Obesity, fatigue, sleep apnea, diabetes, heart disease, cancer, Alzheimer's disease, premature death. If you want to avoid these conditions, or delay their onset at least, live a longer life, get your insulin evaluated, get it working properly. So when it comes to insulin resistance, diabetes is what's really most focused on. And that's the end stage of a lot of this insulin resistance. A lot of people will never get diabetes, but they'll wind up dying of heart disease, cancer, liver disease, other conditions associated with insulin resistance. Conventional medicine is starting to recognize there's a continuum here, and the diagnosis of diabetes has changed over time. Years ago, your fasting blood sugar wasn't considered diabetic until it was over 140. Now it's 125. And I think a year ago, a pre-diabetic condition was recognized. But still, you have to be over here to be considered abnormal. But with the right type of assessment, we can pick someone up early on and stop them from ever progressing to diabetes. The further along this continuum you go, the longer it's going to take to turn things around. And at some point, it becomes irreversible. So I'm going to go through a little more comprehensive look at what causes insulin resistance. First of all, choosing the wrong parents. Anybody out there do that? Have you chosen the wrong parents? Another factor we don't have control over. in utero malnutrition or toxicity. What happens to us in the womb if we don't get proper nutrition, if we're exposed to toxins in the womb? Another thing that's partly genetic, reduced mitochondrial number and function. The mitochondria is where most of the body's energy is produced. And it's been found that children of diabetics have reduced mitochondrial number and function. But this can be improved with exercise, caloric restriction. A number of foods have shown benefit, including olive oil and soy. A number of nutrients, including carnitine, coenzyme Q10, and optimizing thyroid hormone. So there's a lot we can do about this mitochondrial function. Skipping meals contributes to insulin resistance, especially skipping breakfast. Eating too many refined carbohydrates, white sugar, white flour products. The same type of diet tends to be low in fiber. Various nutrient deficiencies. A lot of nutrients play a role in proper insulin functioning. Too much of the wrong types of fat you find in animal fats, and trans fats you find in hydrogenated oils. Eating too many calories, just overeating. Dietary glycotoxins, which contain advanced glycation end products, appropriately abbreviated AGEs. This is a very important subject in itself. I'm going to be giving a lecture on this topic May 1st at the Naval Expo in Huntington, New York. Some details on my website. This is a very important topic. I just wrote an article on. My paper should be published soon. And I'll wind up doing a webinar on this topic in the near future, I'm sure. Very briefly, glycotoxins or AGEs are sugar-damaged proteins and fats that contribute to insulin resistance, do a lot of other damage in the body. And they're found in highest concentration in meats and cheeses, and their numbers are increased by certain cooking methods. Lack of exercise contributes to insulin resistance. Too much fat around the middle. High carbohydrate diets contribute to insulin resistance. This is a pancreatic cell secreting insulin. This is a muscle cell with insulin receptors. And when the muscle cell is exposed to high insulin repetitively over and over again, it tunes out the insulin signal. The number of insulin receptors actually start to decrease, and there's less recognition of the insulin signal. And what causes high insulin? Well, one factor is eating a lot of sugar-rich foods. Sarcopenia contributes to insulin resistance. Sarcopenia is loss of muscle. Stress contributes to insulin resistance. Inadequate sleep. Toxicity from the environment and from the intestinal tract, bacteria in the intestinal tract. Various hormone imbalances impair the functioning of insulin. Inflammation contributes to insulin resistance. Acid pH, high homocysteine levels, low oxygen, cigarette smoking, and certain medications. I could spend several hours on each one of these. These are all important factors. They all interrelate in a web-like fashion. I see quite a few people with diabetes who are taking thiazide diuretics or beta blockers. And these medications actually contribute to insulin resistance and high blood sugar. So an individual may be given a medication like a thiazide diuretic for lowering their blood pressure. That's good. But some side effects of the diuretic are that it's going to cause a deficiency of folic acid, magnesium, potassium, and raise the insulin and the homocysteine levels. And the effect of this can be things like fatigue, heart disease in the long term, muscle pain, diabetes or worsening blood sugar, and even cancer. Conventional medicine focuses too much on a single outcome. The use of medication is very effective in producing a targeted effect like lowering blood pressure, but it causes major imbalances in other parts of physiology, and you can wind up with a variety of sometimes serious side effects. Using drugs to create wellness is like putting a square peg in a round hole. Okay, we're going to spend a little time talking about toxicity and insulin resistance. The study found these findings, coupled with those concerning diabetes prevalence, suggest that organochlorine pesticides and non-dioxin-like PCBs may be associated with type 2 diabetes risk by increasing insulin resistance, and persistent organic pollutants may interact with obesity to increase the risk of type 2 diabetes. They found that people with higher levels of environmental toxins in their blood had an increased incidence of insulin resistance. This was an animal study. They gave one group of animals small doses of an herbicide called atrazine. The other group didn't get the herbicide. Both groups ate the same amount of food, did the same exercise. And what they found was chronic administration of atrazine decreased basal metabolic rate and increased body weight, intra-abdominal fat, and insulin resistance without changing food intake or physical activity level. A high-fat diet further exacerbated insulin resistance and obesity. So to stress this point, without a change in calories consumed or calories burned through exercise, toxicity resulted in decreased metabolic rate and increased body weight, increased fat weight, and insulin resistance. The top map shows the distribution of this herbicide in the United States. Bottom map shows the prevalence of obesity in the United States. And there's fair overlap. Here's another study looking at the connection between 6 different classes of persistent organic pollutants and diabetes. There were striking dose-response relations between serum concentrations of 6 selected persistent organic pollutants and the prevalence of diabetes. So hopefully you're starting to get the picture that toxicity contributes to insulin resistance. Diabetes is one of the conditions that results from insulin resistance. So to deal with this, we have to address toxicity. You have to try and reduce the toxins going into your body and take steps to get rid of stored toxins, and in many cases, laboratory testing to see what toxins are there and how much there is a smart thing. Although both beneficial health effects after weight loss and harmful health effects after weight gain are generally expected, changes in serum concentrations of persistent organic pollutants in relation to weight change may act on health in directions opposite to what we expect with weight change. So this study and others have found with weight loss, there's an increase in toxins, environmental toxins in the blood. And the reason for this seems to be that fat-soluble toxins that have been tucked away in body fat get released into circulation when you lose fat. And if the body doesn't have the ability to process and eliminate these toxins, they stay in the body, obviously, and they can do damage. This study looked at the connection between body mass index, how fat people are, weight versus height, an enzyme called GGT, which is associated with toxicity, and type 2 diabetes. Body mass index was not associated with prevalent type 2 diabetes when GGT was low normal, suggesting that obesity itself may not be a sufficient risk factor for type 2 diabetes. So body fat interplays with toxicity to produce diabetes. When a person's not toxic, the increased body fat doesn't have as much of a negative effect, doesn't contribute to insulin resistance nearly as much as when toxicity is a factor. There's a number of ways to look into toxicity. One test for toxicity is a functional test. This is a test I do in the office, functional acuity contrast test. It determines an individual's ability to see various shades of gray, and the ability to see shades of gray become impaired with neurological toxicity. And there's been studies, a number of studies finding connection between levels of different types of toxins, different classes of toxins in the body, and impaired ability to see these shades of gray. Okay, on to another topic, blood sugar, hormones, and stress. When we eat food, our blood sugar goes up. The insulin goes up. The insulin lowers the blood sugar. When the blood sugar comes down, other hormones go up in response. Glucagon, cortisol, epinephrine are some of the hormones your body uses to pick the blood sugar back up. Cortisol and epinephrine, or adrenaline, are stress hormones. Drops in your blood sugar cause your body to release stress hormones. A drop in your blood sugar is stressful. If your blood sugar is continually seesawing up and down, you're continually being exposed to spikes in stress hormones. Having a seesaw in your blood sugar is a source of stress. Just like mental emotional stress, it produces release of the same hormones. So you want to keep your blood sugar level. These are graphs of changes in blood sugar, fatty acids in the blood, and insulin in response to drinking sugar solutions. Two groups of people drank the same 50 grams of sugar. One group drank it in 5 minutes. The other group sipped it slowly over 3.5 hours. The group that sipped the sugar solution had very steady blood sugar over the course of the study. Black boxes are the blood sugar values in the group that drank the sugar down quickly. And look at the insulin. The insulin mirrored the glucose or sugar in the group that sipped it slowly. The group that chugged down the sugar solution had a huge outpouring of insulin. This is all fat-forming, inflammation-producing, cholesterol-stimulating, very unhealthy. And we see the effect, a delayed increase in fat in the blood in the group that drank the sugar down quickly. So you don't want to drink sugar down quickly. You don't want to have a lot of sugar all at once. You don't want to eat foods with a high glycemic index, which refers to how quickly they're converted to sugar. You want to eat small, frequent meals that are low in glycemic index. Not a meal like this, although that does look tasty. 12 ounces of soda has 10 teaspoons of sugar. How much sugar does a normal person have in their entire bloodstream? Maybe 1.5 teaspoons. So if you're drinking a can of soda, 10 teaspoons of sugar, that's a lot of stress on your body to regulate that amount of sugar coming into your blood. When we eat foods with a high glycemic index, like a cookie, blood sugar goes up rapidly. We wind up with high insulin levels. The insulin causes a drop in the sugar, low blood sugar, and increased fat storage. Low blood sugar leads to increased hunger, increased cravings for high glycemic index foods, and around you go. So we need to break this vicious cycle. You have to start off with a good breakfast that's low in glycemic index, like eggs, for example. These are foods with a low glycemic index. These are foods with a high glycemic index. This is not a comprehensive chart. There are definitely more detailed charts available. As a rule, whole unrefined foods are going to be lower in glycemic index compared to refined foods. Where are most of the insulin receptors found in the body? This is important. They're found in the muscle. So if you have more muscle, you have more insulin receptors, you're able to use more insulin and take up more sugar. That's better for the whole process. Low serum creatinine is associated with type 2 diabetes in morbidly obese women and men. Low skeletal muscle mass is associated with insulin resistance and metabolic syndrome. Serum creatinine may serve as a surrogate marker of muscle mass. Creatinine is a breakdown product of creatine. 95% of the body's creatine is in the muscle. If you have a higher creatinine, you more likely have a higher muscle mass. Low serum creatinine is a predictor of type 2 diabetes in Caucasian morbidly obese patients. Now, interestingly, creatine has a beneficial effect on insulin metabolism. If you combine creatine with exercise, you get improved insulin sensitivity compared to exercise alone. This is my wise guy cartoon. A lot of you have seen before if you've attended my webinars or seminars. Tell me, Mr. Smith, what fits better into your daily routine, 1 hour of exercise or 24 hours of bed? Can't underestimate the power of exercise. To make your insulin work better, I recommend a Mediterranean style diet. These are some of the foods that have research in making the insulin work better. Soy, cold water fish, green tea, cinnamon, garlic, onions, black pepper, buckwheat, vinegar, dark chocolate, legumes, fruits and vegetables. This is the type of diet I teach my patients to eat, Mediterranean style diet. Got a lot of research for making insulin work better, improving risk to cognitive decline and Alzheimer's disease, all kinds of health conditions. To improve your insulin functioning, exercise, both resistance and cardiovascular exercise, follow a Mediterranean style diet. Use cold water fish, fish oil, maybe borage seed oil, monounsaturated fats, nuts, olives, avocados. To this list, I should really add medium-chain triglycerides like a good quality organic coconut oil, high-soluble fiber, pectin you find in apples, oat bran. Eat frequent smaller meals, about 5 or 6 times a day. Many nutrients are important. Everybody should have the vitamin D level tested. I like to have my patients tested for as many nutrients as possible with an individualized optimal nutrition profile. We learn about need for these nutrients and more. These are some of the minerals that are important for making the insulin work properly: chromium, vanillin sulfate, magnesium, zinc. Reduce stress. I often recommend doing a salivary test for stress hormones, cortisol, and DHEA. Insinase. This is one special supplement with some interesting research. This is derived from plant substances. The research that went into developing this product involved a company called Metagenics set out to create a supplement to improve insulin sensitivity. So they looked through scientific literature what natural substances had the best research for making insulin work better. Then they did their own testing in the laboratory, and they found the top few plant extracts that were the most effective. Then they combined them in different concentrations. And they found a concentration that was synergistic. So the individual components, when combined, were more effective than the individual components by themselves. And they did animal studies and human studies, compared insulin against medications. This was the results of an animal study. Control were animals that got no treatment. This is blood sugar change from the beginning of the study to the end, and this is insulin change. Conventional treatment 1, conventional treatment 2, these are diabetes drugs. One is Avandia, the other one is metformin, and this is the insulin. This is the change in blood sugar. So the drugs were slightly more effective, but the insulin was close to as effective in lowering blood sugar, and the insulin was just about as effective, more effective than one of the medications in lowering insulin levels. And the insulin didn't have the side effects of these other drugs. The Avandia can have some pretty significant side effects, cardiovascular effects, I believe. This is a medical food for making the insulin work better. I often use this. This is like a meal. Got protein, carbohydrate, fat, fiber, vitamins, minerals, amino acids, plant extracts, all designed for optimal blood sugar and insulin metabolism. So I often have patients use this as 1 or 2 meals a day, in addition to 3 to 5 other regular food meals. To improve your insulin resistance, well, first of all, it's a good idea to see what kind of shape your insulin functioning is in. Have a thorough, holistic evaluation. See how well your insulin's working. And if it's not working 100%, have an evaluation to identify the contributing factors in your case, then your program can be tailored. This is what my website looks like. If you go to my website, you click on the articles button, read my articles, and you can sign up for future webinars. There's a lot of information on my website. You can do a search, any topics you're interested in. Okay, at this point, we're ready for questions. You should be able to type in questions on the right side of your screen. I'll read the questions, do my best to answer. I'll probably do another webinar in a few weeks. I'll be sending out announcements prior to give you time to sign up. If you have an interest in this topic, like I said, the second article on my website discusses this topic of insulin resistance. And if everything goes well, I'll be putting this recording on my website. Okay, we'll give it just another minute or two. If anybody would like to ask a question, you can type that in on the right side of your screen. Find the question box. Okay, everyone. Looks like there's no questions. Thank you for attending. Hope you enjoyed it. If you'd like to contact me, you can always get my contact information from the website. You can email me directly from the website. Feel free to give me a call. And hopefully we can do this again soon. Thank you, everyone, and good night.